Oh, hello again, mathletes. Okay, so we're going to jump right into the examples here. These are some examples that might not match up with some of the other stuff we've done. So I want you to see some of the oddballs here too. So let's just go ahead and get started here. First one we're looking at is 3x squared plus 6x is equal to 0. All right, so when we approach this, we already have the 0 on one side, and so it's just a matter of factoring the other side. Now, this isn't particularly difficult to factor, but it looks different, right? It doesn't have that full quadratic form. There's not three terms on the other side, so a lot of the time that throws you off. But one of the things to notice is that I have a common factor here, right? There's a common factor of 3x that I can pull out of here. And 3x is a factor. And so let's see here. That's going to leave me with x plus 2 equals 0. And at this point, we actually have it completely factored. You notice on all of our x's, the exponent is 1. And so that means that's as far down as I can go. I can't have an exponent less than 1 in this case. So I have two factors here. And so what I'm going to do is set each of them equal to 0. So either 3x equals 0 or x plus 2 equals 0. Right? And so we've almost just jumped to the end. This is one of those ones where all you have to do is factor out a common factor, and you're done factoring. So this first one here, 3 times x equals 0, the only choice is that x is equal to 0. That's the only possibility. Or over here, if I subtract 2 over, I get x is equal to negative 2. And so I end up with two answers. I have x equals 0, and I have x equals negative 2. Right? And those are my two solutions to this one. Now, so let's go ahead and look at the next one here. Let's go ahead and pop that up. And the next one here, there's a real tendency whenever you see these things to immediately, you have a square on one side, to immediately want to take the square root of both sides. Now, there's a little problem with that because there's a property of square roots that we haven't talked about. And if you try to do that immediately, you only get one of the answers. And so at this point, we really do have to use factoring to solve this. And if I'm going to use factoring, that means I need 0 on one side. And so I'm going to subtract 16 from both sides so I can have a 0 on one side. Now, there's a couple of ways to handle this one. The first thing to notice, though, is that you have a common factor on the left-hand side. There's a 4 that's common to both terms, not a 4x, but just a 4. And so I'm going to pull out the 4, and that leaves me with x squared minus 4, 4 times x squared minus 4 equals 0. I'm not going to be able to factor 4 anymore, at least not for any use. But we do notice that x squared minus 4 is the difference of squares. And so that means a full factorization here would look like this. Right? We have x minus 2 and x plus 2. So 4 times x minus 2 times x plus 2 is equal to 0. Now, technically, we should be solving the equations that result from setting each factor equal to 0. So I'm going to go ahead and do that. So 4 is my first factor. X minus 2 is my next factor. And then x plus 2 is my last factor. Now, can 4 ever equal 0? No, it can't equal 0. So that one's not going to yield me any kind of solution. There's no x to plug into, so it's not going anywhere. But x minus 2 equals 0 gives me the solution x is equal to 2. And x plus 2 equals 0 gives me a solution x is equal to negative 2. And so I have two solutions here. I have x is equal to 2, or let's put negative 2 first. And so x is equal to negative 2 and x is equal to 2. I also want to show you a little shorthand for compacting this. Now, I'm not sure if your homework will take this, but it is a notation we're going to be using pretty soon here. So one of the ways you can indicate both the positive and the negative values for a number or an expression is by using this notation. X is equal to plus or minus 2. And it's just understood that that is both answers, right? So either of these things are perfectly acceptable as far as answers go. Okay, so let's go ahead and take a look at the next couple. Or I should say the next one. Okay, so the next one we want to look at is 2x cubed minus 4x squared minus 70x is equal to 0. Now, we already have the 0 on one side, so I don't have to worry too much about finding that 0 over there. But I do need to factor the left-hand side. And you notice here, one of the first things you always want to do when you start factoring is there a common factor? And you can see there's a factor of 2, everybody's even, but also there is an x in every term. And so that means that I can pull a 2x out of here, and that's my first factor. So let's see what we have left. 2x times x squared gives me 2x cubed. 2x times minus 2x gives me minus 4x squared. And 2x times minus 35 will give me minus 70x. All right, so I have two factors now. So the idea is to see whether this guy factors, right? So we have to see if that guy will break down. So we'll go ahead and set up for this trinomial here. We'll set up our master product. So that's going to be a 35 in this case. And the sum I want is negative 2. Now, if you go down your list of things, 35 doesn't have too many factors. It's either some combination of 1 and 35 or some combination of 5 and 7. And in this case, it's going to be the 5 and 7. Negative 35 is negative. So that means the two numbers I multiply have to be a positive and a negative. Otherwise, I'm not going to get a negative product. And if I'm going to add them together to get a negative number, the bigger of the two factors has to be negative. So this gives me negative 7 and 5. And since we have a 1 as a leading coefficient here, I can jump straight to the double bubble. So I have 2x, right? That guy's just dropping down. And then we can throw our double bubble in here. Will be x minus 7 and x plus 5. And that whole business is set equal to 0. Now, in this case, we have three factors again. All of them have an x to solve for. So that means we're going to yield three solutions for this. So that means that either 2x equals 0, x minus 7 equals 0, or x plus 5 equals 0. All we have to do is solve these three equations. So it's going to yield us three solutions. Well, here, 2 times x is 0. The only way that happens is if x is 0. So that's one of my solutions. And then here, if I add 7 over, I get x is equal to 7. That's another solution. And over here, if I subtract the 5 over, I get x equals negative 5. And so I have three solutions here. I have x is equal to negative 5, 0, or 7. All of those will work when you plug them into the original equation. And I'll leave those to verify for yourselves. Okay. So we've gone through a bunch of examples. We've seen why it works. And the whole idea of pretty much all of these is the same thing. To use the zero product property to solve, you need to get the equation equal to 0 first. You need to factor the non-zero side into as many factors as you can get, and then you set each factor equal to 0 and solve the resulting equations. And you should have as many solutions as factors, although sometimes you get the same solution twice, in which case you only need to list it once. All right, so that concludes our lecture on solving polynomial equations, and I hope it was clear. Make sure you go and solve polynomial equations, and I'll have the homework up a little bit later. Thanks.